Hello everyone, in this tutorial I will show you how you can get a simple model with no detalization and transform it into something beautiful, very interesting looking with a lot of details. In the first block of this video I will show you how to create a technical setup, and then in the second block how to split this onto the 3 layers and render this with the Redshift. If you don't understand something, you can go to my Gumroad, the link in description, and take the project files and much more. So good luck and let's start. So let's create a geometry and let's create a file, and there is some example file which I have already. This is our rocket. So this is an FBX file and it has a lot of attributes. We don't need so many attributes, and let's delete some of them. Let's delete FBX rotation, scale and translation. Let's delete material, show path, max handle, name and warm up. And what we have now, we have only normals and UVs, which is okay. Let's subdivide our geometry a little. I think 2 is okay. So, and let's check our UVs. So they seem to be a little big. So let's transform the UVs. UV transform and scale it up a little, or something like this. Okay, so now we have UVs, and now I want to scatter points over the surface and use these points as a source for the blocks. So for selecting the blocks from this geometry. So we could use a scatter node for this, but this node gives us irregularity between points, and we could also use a points from volume node, which has a better regularity. Okay, but before I do this, I forgot something. So now the scale of the model is very big. Let's transform it down. Oops. Transform, scale it down, and move centroid to origin, by the way, and scale it down to something like this. So now it's not so big. So again, attribute delete, subdivide, UV transform, and points from volume. Now it works. So you can see now the regular grid. They are well arranged, and you can be sure that the distance between 2 points are the same. Of course, you don't have these points in very thin places, which shouldn't be a problem at all, but you can also use a scatter and play around with this. So I will use the points from volume for now. So the other problem is that they are sorted. The points are sorted along the x-axis, and let's sort it a little bit more random. So that's better. Let's create a null. So this is a null, and for now it's okay. Let's start creating a for loop system, for loop with feedback, and connect the UV transform to this for loop feedback. And let's immediately create a meta import node, which allows us to get access to the iteration attribute inside. How many iterations we have, we can define here in the repeat end node. We have 10 iterations for now, and I want this number to be So I want this points from volume attribute to be the source of these iterations. So I want the number of points here to be the same like iterations here. Let's name this null as endpoints, and we can use a simple expression here also endpoints, and we can refer to this node endpoints. Okay, now it's 488 points, 88. So here we have the same number. Okay, let's start grouping points. So we need to group this geometry, and so there is points mode here, and we want to group these points, keep it in bounding regions, and select bounding objects here. So I want to select box. So now we can move this box, and this will group our points somehow. And I want this box, each iteration, to be in the different place. So, and we will use our scattered points for this. And I want to somehow to get random points inside of each iteration. So, and I will do this with a wrangle. Let's connect the endpoints node to the first input, and the second input will be connected to our metadata node to get access to the iteration attribute here. Let's get this access. So this is integer attribute. Let's name this attribute iteration, and this is a detail attribute which we can read from the input 1, which is the second input, and the attribute is the iteration, and the number is 0 because it's a floating attribute. And now if the current ptnum, the current point number, is not equal to this iteration, then we remove this point, which means that each iteration, every point but one, which is current iteration, will be deleted. So you can see immediately that there is only 1 point left, and if we will change the iterations, so you can see it right now, but it will work in the next iterations. We can see this. So now I want to use the positions of these points in this box node. Let's create a null and name it out center. And let's use this center here in box. So here we can use in the center centroid. Let's refer to this node out center. And we need the X position of this centroid, and for Y axis we need the Y position, and for Z we need the Z position. Now if we switch to this box, we can see that this box is transformed, so from center to this point which is here. And what we can do now, we can also change its size. So I want this box, so we could change the size manually, but if we want to be sure that every single piece of source geometry is covered by these boxes, we could use the distance between points. And the distance between points in this case is equal this point separation, and we can use this point separation as a reference in the size. So let's use just channel, and let's refer to these points from volume attribute node, and the particle separation parameter. And because the box is it has to be extended to the both sides of the points, we need to multiply this by 2, and that's we will also use for all the axes. So the actual size is 0.0, and if we will change this to 0.0, the size will be 0.4. So that's what we need. So now we have this grouping. So, and after all the iterations, we will have a complete geometry covered by these groups. So we can't see this right now because each iteration this group overrides itself. So this group overrides itself, and let's deal with this. So first I need to promote this group from points to primitives. So from points to primitives, and now I want to name. So name is a string attribute that can be based on the group, and what we will use here, we will use the group 1, and the name will be, for example, a piece. And now every iteration we need a unique number of this piece, and this unique number we will get sure from the metadata node. So let's open a backtick and refer to this iteration. So this is repeat begin 1 metadata 1, iteration like we did it before, and the number is 0 because it's a floating attribute, and the closing backticks. And now you can see if we middle click on the name that the current iteration is the last iteration, and we can see that the number is equal to this iteration. Now let's execute all this loop, and we can see that we have 157 unique names. We can check it in the geometry spreadsheet, and this name attribute is a primitive attribute, and you can see that okay, some of them are empty, but the rest has their unique numbers. And I think that some of the attributes are empty because we don't have enough points in these scene areas, which you could notice before. So here in the point of volumes we have not enough points here, and if we used scatter instead, maybe it will solve our problem, but we will have another problem with the distance between 2 points. So I will prefer to use this one, and let's see how it will work. So I think we can use now an explosion view, so exploded view, to see how it works. So the piece attribute is a name. So that's how it works. So this is 157 different pieces, and as you can see, everything works as expected. Okay, so now instead of exploring this, we could use a color to colorize different pieces based on our name attribute. Now you can see the different pieces, and now you can finally visualize what happens if we change these points from value size. So if we pick a very high amount, so it means the very big distance between points, we will have a little pieces, a little amount. And if we will select a high amount of points, we will have a lot of pieces, but no more than polygons, of course, but something like this. So, and let's use this default value. And now I want to prepare this to animation. So how I can easily animate these pieces? So the easiest way is to convert them to points. So each piece would be 1 point. So we can do this with assemble node, which packs our fragments. So we don't need to create name attribute because we already have one, and instead we will create a packed geometry. And now you can see that in the center of each piece we have a single point, and these single points we can delete or something. So let's, for example, put down a blast node, and let's say that 0. So this is a 0 attribute, 0 number of points. So as you can see, it's a whole number of pieces, but it's because we don't have enough points here. So this is 1, 2, 3, and so on. So we have all these single points here. Let's now assign an ID attribute, which is ID. ID is integer by default, so ID is ptnum. And let's create a rest attribute, which I prefer to use my own pointer angle instead of the rest node. So vector rest is p. Let's rename this ID to set ID. ID is useful when you are planning to change the number of points in future during the animation. We don't plan this, but it's useful to have these IDs anyway, because I don't know, it's useful, just believe me. So, and this is a rest attribute which is equal position. So, and this is the same. If we are planning to change the position in future, and we are planning, then we will have at the same time the rest attribute in the rest position, which keeps not changed position. So that will be set rest. So let's animate these points, and let's animate them procedurally. So how we can animate this? So first we need to define So I want each point to be offsetted by from the center. For example, these points will be offsetted from here, these points from here, and so on. So we will need the axis of this rocket. So let's create this axis with a line. So the line, let's line. So let's orient this along the x-axis, -x, 0. So we have this line. This is our axis, and let's resample this line to get more points, maybe even more. Okay, and now let's create a rectangle where we will define new positions. So let's name it define new positions, and in the first input we will connect these points, and in the second input we will connect this axis. So let's switch them. Okay, now I see that it's time to explain a little what I'm going to do. So what I'm going to do is to create, so I have already created this axis line. I have already created points on this line, which is the axis. And now I want to go through all the points on the geometry. For example, let's take this point. I want to find the nearest point on the axis, calculate a vector between them, and use this vector as a direction for the offset. Let's find this point. Near PT axis is near point. We use the second input, where the axis is, and we will find this point based on the position of the current point. Now we got this point. For example, it's number, I don't know, so number 2. We got this number, and now we want to get a position of this point with number 2. So let's get a position, which is a vector. Position axis is point, second input, position attribute, and the number of point which we just found is a near PT axis. Near PT axis. Now we have the position of the original point and the position of the nearest point, so let's calculate a vector between them. Vector direction, vector direction is normalize, because I wanted to be this vector to be normalized. Position minus position axis. This is our vector of direction. And the last thing we want to do is to check if we have made everything okay. So let's assign this position. So the new position will be our initial position plus our direction. Okay, that's how it looks. Let's add some offset number, so we can control with a slider. Okay, this looks good. And I want also to add some randomness, so let's add some random, float rand, and let's base this random on ID. So, and let's add this random here, so multiply by rand. Okay, now we have this randomness. And what I don't want right now, I don't want to change the actual position, but instead I want to use a new position attribute, which is vector, to be used later as a final position in the animation. So as you can see, now we have a new position attribute, which is our new finally offset position, and we have a rest position attribute, which is our initial position, and we can use a blend factor between them to define in which period of time we can animate this. Okay, now I'm ready to create some animation. We will use this P attribute and the rest attribute and the blend between them. Oh no, the new P attribute and the rest attribute, or P attribute, doesn't matter. Okay, pointer angle. So let's create this P attribute. Let's blend these two created attributes together, so P and new P based on blend. So what we have just done, so we are trying to blend the original position attribute with the new position attribute based on some number which is unique for every single point, and which is float from 0 to 1, which is blend. But we don't have this blend variable here, so that's the problem. So let's create this blend. Float blend is 1. So 1 is the new P and 0 is the old P. So let's define it as frame. So now we can see the constantly increasing distance, but let's remap this frame now. So for example, from 0 to 50, from 0 to 1, and it means that 0 frame is 0 and 50 frame is 1. So we can see that the animation goes from 0 to 50 now. It's a linear animation now. Let's complicate it a little bit. So let's use the ramp function with the animation inside, and this range will be a control range. Let's create this curve and use the B-splines as a control curves. Now you can define this procedural animation and you can create your own curves. Now it's smooth. You can even do something like this. This will be very teary, but that's not what we need. So okay, now let's complicate things a little. Let's create a random number which is float. Let's create a random based on our ID attribute and multiply this with a spread value, which we can set by as a 10, for example. The more this value is, the more randomness will be between the pieces. And let's create a start frame, which is integer. Start frame, so frame start, and the length of the animation, the base length before the randomness will be applied, is the length. Okay, and the other thing that I want to round this this randomness down with the floor function because it's an integer attribute. So now let's replace this 0 with a start frame plus rand, plus rand, and this 50 we will replace with start plus length plus rand. And now we can see that okay, start frame and length. Start frame is 0 and length is 30. Let's see. Okay, it works. Start frame is 30. Okay, it works. Length is 10. Okay, it works very fast. Spread is 90. Okay, it works. So everything works, and that's how you create a procedural animation. Let's name this node Deconstruction. Let's set the parameters like here. So 15, maybe 20. Let's copy this node and let's name this node Construction back. And the only difference between them is that we will use instead of the new p, we will use the rest attribute. So this is inverted version of our animation, and the only thing we have to do is to change the frame start. Now it's, for example, 40, and the spread, the spread we can leave as it is, or we can change it a little, doesn't matter. So now you can see that at frame 15 it starts deconstruct, and then at frame 40 it starts construct back. So this is a fully procedural animation. So I'm going to prepare render, and as you can see that we have packed fragments. Let's unpack them. And because before we had this ID attribute and now we don't have this ID attribute, let's add this attribute. Let's transfer this attribute here. So now we have this attribute, and let's now delete these technical colors and add the normal color here. So before we did this, we will use a color attribute for randomness. We will use this ID attribute for randomizing the colors from 0 to 1. And now when we have this attribute, we can use this attribute color to create this look. Now we can use this attribute ramp to create a desirable look. Let's create something beautiful. For example, here, here, and here. So a little bit green, a little bit white, but mostly yellow. Now I will explain what I'm going to do. So that's our final render. So, and it contains 3 layers. The first one is glass, which is solid, and this is a basement with reflections. The second one is wire, which is perimeter with a self-illumination material. You can see this. And the last one is detailization, which is a texture layer. It has a texturized geometry, and you can see the extra details here. This is a texture layer. So we have these 3 layers. Let's add them to our setup. And now we can export this as a glass. This will be our glass. So the second one will be the wireframe. So how we can do this? We can group edge with the unshared edges. So, and then we can name this group as edges, and then we can dissolve everything which is not edges, delete non-selected, and with remove inline points off, because we need this round corners, and then convert, not usual convert, but convert line. Now we have these lines, and what do I want right now? I want to set intensity attribute. So the attribute which called int, and I want to say that this attribute will be somewhere between 0 and 1, but more 1 than 0. No, more 0 than 1. So there are only few of the points that will be bright, and the rest of them will be nearly black, so very dark at least. Let's apply this int attribute to the color, and we can see difference immediately. Let's multiply the color attribute with this intensity attribute, but before multiplying this, I want to fit this attribute actually. Int. Okay, we can't use int, let's use intensity and rename it later. So the original attribute is between 0 and 1, and we can remap it with fit 0, 1 to 1 and something else. So here we can also intensity, rename it, and now this intensity will be what we need. So now you can see the difference immediately before and after. Some pieces became brighter. Apply int, set int. Let's export this branch as outwire, and the last branch will be our, let's check. So the last branch will be our text, and we can only check before exporting if it works. So let's select some texture, so how it lays, it's okay. I would like to see more diversity between them, but since we use here only one frame, it's okay. So in future, in my next tutorial, or you can see this in my Gumroad, I can show you how to use all the full range of frames, animated, looped, and so on. But for now we can use only one frame. It's okay. So let's export it as texture. Now go up. This is our setup. We can disable it, and let's create 3 geometry nodes with a render glass name, render wire name, and render text name. Render glass will be with the single object merge side, rend out glass. Okay, so we can copy this, paste here, and this will be render wire, out wire, and here it's render text. Let's create materials for them. Redshift material builder. So the first one is glass, the second one is self-illumination, and the third one is texture. A glass material is simple, it's just reflection and refraction material, so a little bit refraction here. And we can also use the color, Redshift user data color, and take the color from the geometry. We put this into the diffuse color. Okay, and now it's very straightforward to apply this to this material. So this is a glass. The wire material will be the self-illumination, so we can use Redshift incandescent material here, and also we can copy this user data color here and use it as a color here. Let's apply this to render wire. And the third one is render text. Let's create again one incandescent material. We will use the Redshift texture for this material. Let's pick some frame out of our base, and before applying, let's multiply this with a color, because we want to colorize this texture because it's black and white, and by multiplying this black and white texture with a color, that's the way how you colorize it. Let's append it to the color, and let's append the color to the alpha, but because the texture is very dark, I would use the change range and make it more contrast. That's how you make it more contrast. Let's apply this texture now to the render text. Let's create some camera and position it here, because I have watermarked render and I don't want the watermarks to be here. So something like this. Let's create some light. I would use light dome, and I have my own texture that I use, large 5. You can get this texture on my Gumroad. So enable the new ports, okay, enable background, disable. So we are ready to render. Let's go to Redshift render. What I just did, I just pressed 3, and so we are now in render nodes. So candidate objects, these are objects that can be rendered, so this is render objects with a star, and I think that we can render it as it is, but I just remembered that we didn't do the thing, that this glass and this text actually has the same coordinates, which is bad because they are coplanar. Therefore we need to poly extrude this texture before you use it. Let's extrude it a little, and now okay, and I also want to use this intensity also in this texture. That's better. Okay, now I think it's ready to render. Let's check. Okay, we got something. I obviously can see the glass and I can see the texture also, but I cannot see the wire because we didn't do the sync. Inside of the wire node there is an option that we can use the lines and render this as strips with a little multiplier. Let's try. And now we got it. So we got this result. It looks nearly the same. The rest of look we could do with compositing, which I make in After Effects. The background, the glowing, the color corrections and so on. But that's so we can cover this in the next tutorial, and also I can show you how I create this plexus and how I loop this texture, so it's different on each piece, how I create depth of field and so on. And if you can't wait, you can go to my Gumroad, which link in the description of the video, and you can get this asset which has a lot more functions that I described in this tutorial, and you can take a sneak peek inside, so what I added there, and get this texture and all the material I used in this tutorial and more. So I wish you good renders and good luck. See you!